Hello, class. I have the Unit 3 test review here that we're going to go over. The first one here wants to determine if this relation is a function, give its domain and range for this relation. So for 4, 1, 5, 3, 7, 7, this is a function. The domain are the values of 4, 5, and 7. The range 1, 3, and 7. For number 2, determine if this one is a relation, if this is a function, give its domain and range. 4, 1, 4, 6, 7, 1, and 7, 6. Since we do have those x values being repeated here, this is not a function. The domain will just be 4 and 7. The range is going to be 1 and 6. For the third one, same thing. This one is a function. Its domain is going to be -7, -6, -5, and 5. And the range will be the same numbers. -7, -6, -5, and 5. Number 4 wants to find these different values based upon this function I have here. 2x squared plus 4x minus 5. So f of 0, I'll just make -5. But f of 2, so 2 times 2 squared, so that'd be 4 times 2, so 8, plus 4 times 2, which is another 8, so that's 16, minus 5, that's 11. F of -3 would be 2 times -3 squared, so 9 times 2 would be 18, plus 4 times -3, which is -12, so that makes 6, minus 5, this would be 1. Then for the last two, f of b would just be 2b squared plus 4b minus 5. F of 4a could just be slightly simplified. This would be 4a squared times 2. So 4 squared is 16 times 2 is 32. A squared plus 4 times 4 is 16. A minus 5. Number 5, I give this piecewise function, and I want to find its indicated values. So f of x is equal to 4x plus 6 if x is less than 0, 7x plus 8 if x is greater than or equal to 0. We want to find f of -6. So our top equation, 4 times -6 plus 6, -24 plus 6 will make -18. F of 0, which will be the bottom equation, will just be 8. F of 5, 7 times 5 plus 8. So 35 plus 8 is going to be 43. And then we need f of -100. So 4 times -100, so -400. -400 plus 6 will be -394. F of 100 will be 7 times 100 plus 8. So 700 plus 8, 708. And we want to add these two together. So doing so should make 314. When we add these two values together. The sixth one wants to graph these functions f and g in the same rectangular coordinate system, which I copied from the actual my math lab, and as you could tell, not exactly the nicest to do, and it's such a enclosed spot. But this wants to use f of x is equal to x squared, g of x is equal to x squared minus 9. So let me actually just set up this table so we know what we're actually graphing. All right, so for f of x squared, negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. So that, let me pop these in here, looks something like this. Of course, the problem being with it being such a small graph, not the easiest to graph on, I know. But those are the 5 points. Connecting them with a parabola looks something like that. For g of x, we would subtract each of the values we just got by 9, negative 5, negative 8, negative 9, negative 8, negative 5. So these ones look something like this, which again I know, not the nicest to be graphing in such small conditions. But that would look something like this, which per the way this parabola is basically just shifted down by 9. Which is how we could get such a graph from this. Again, in such small conditions. Number 7 wants to use the vertical line test to determine if this function of x, if this is a function of x, which, I mean, we could draw a line anywhere. It's going to hit it once. So this is a yes. And this one, we would have to be careful, right? If we did it like right here, it hits it once. But if we did it over here, it hits it twice, right? So since it does hit it twice in some spots, this is a no. Number 9, using this graph to complete each of this following, which it was kind of hard for me to keep on the page so we could see all those, but get to these parts as many as possible without having to hide anything. The domain is going to be all real numbers since this keeps going to the left and it keeps going towards the upper right portion of this, so it continues in both directions. The domain continues to increase even though the left side just continues to stay the same. But the lowest value here is negative 8. Includes the negative 8, so bracket negative 8 to infinity. F of 2, the function value at 2 is going to be, it's not there. There, it should be a value of 7. The x values of x for f of x is equal to negative 8. Negative 8 will be there and there, so that should be 7 and 9 in our case. We want to know where this crosses the x-axis, so that being 5 and 11. Where it crosses the y-axis, which would be over here, at the point 0, 7. Probably should actually write this little e like this. 5, 0, and 11, 0. Except making it seem like those are points. Find the values of x for which f of x is less than 0, which in this case would be between those 2 points where it hit 0, which would be between 5 and 11, before it falls below 0 there. Or as a set, that'll be 5 to 11. And is f of negative 7 positive and negative? Since it continues to go to the left there, it should be positive. Number 10, what's the domain of 6x plus 6? That's a polynomial. This would be negative infinity to infinity. Number 11 was the domain of 11 over x plus 12. We cannot have a value of x to be negative 12. So negative infinity to negative 12 parenthesis union negative 12 to infinity. We want f of f plus g of x and f plus g of 2. But f of x is 3x squared minus x minus 1. G of x is x minus 5. So for f plus g of x, 3x squared minus x minus 1 plus x minus 5 is 3x squared minus 6. And popping in 2 into that would be 3 times 2 squared, so 3 times 4, which would be 12, minus 6, so it makes 6. For f minus g of x and f minus g of 7, with f of x being x squared minus 3x, g of x being 9 minus x. So f minus g is x squared minus 3x minus 9 minus x. So x squared minus 2x minus 9. And f minus g of 7. 7 squared, so 49 minus 2 times 7, so 49 minus 14, we're going to have 35 minus 9, so 26. Well, f of x be x squared plus 5x, g of x be 3 minus x. We want f times g of 5. So for this, we could put 5 into both and then multiply. F of 5 is 5 squared plus 5 times 5. So 25 plus 25 is 50. G of 5 will be 3 minus 5, so negative 2. So F times G of 5 would be 50 times negative 2, so negative 100. And then this last one. F of x is equal to x squared plus 9x, g of x being 2 minus x. We're at f divided by g of x, which we can't really simplify too much. X squared plus 9x divided by 2 minus x. We could factor out the x in the numerator, but it's not going to cancel with anything, so I'll just leave it the way it is. And f divided by g of 3 would be 3 squared, so 9, plus 9 times 3, which would be 27, divided by 2 minus 3. So we have a negative 1 in this denominator. And what did I say this was? 9 plus 9 times 3, so 9 plus 27 should be 36. Divided by negative 1, so negative 37. Let me know if you have any questions or concerns. Thank you.